So today we're going to be looking at Mike's 902 transmission. This transmission came to us, Mike brought it over and dropped it off. Came to us already disassembled. There's usually some things that I'm looking for when I disassemble, and those we're going to be missing a couple of those, particularly the gasket thickness, which is not a big deal. We'll figure it out anyways. But we need to disassemble the gear sets, take a closer look at our synchros. Right now, with a quick look, everything looks pretty good. So we don't know anything about it as far as how many miles are on it, whether or not it's been rebuilt before. Being as old as it is, there's a large possibility that it probably has been serviced. Mike has already gone ahead and pulled out some of the detent springs that live down in here. And these detent springs, what they do is they lock the shifters into place. So I'm going to finish up getting the shift forks out, and then we'll get the gear sets apart, get it in the press, get it pressed apart, and lay everything out so we can clean it and inspect it. Okay, so I'm just going to slide that. I've just pulled the bolt out. These shouldn't be too tight. They're 25 Newton meters is the tightening torque. And then I'm just going to slide that out. And I can slide it back on if you like to keep it all together. And we'll clean these up individually. So now I've taken out the first shift fork. There's going to be a detent that's located right in between these two. I'm just going to take a magnet, come down here, and you can see that detent. Now the purpose of that detent is when I engage my first reverse slider back or forth, we've got these little knobs right here, and what that does is it locks. This detent will get pushed up against our gear shift for our second, third shifter, and will prevent it from moving. So if you forget to install this, there is a possibility that you can engage two gears at once, which will lock the transmission. It will not be able to drive. Okay, with that one out, I'm going to take my second, third shifter off. So all I've got to do is slide it that far, and then I can just slide that shift fork off. You can take it off if you want. Then the same thing, I'm going to have another detent. Now between here and here is going to be a ball and a spring, and then another ball all the way down. So there's the ball. I usually like to throw all that stuff in a magnet tray just so it keeps tabs on it. Come on, spring. My spring is pushing off to one side, and then it's just getting stuck coming through this port. Okay, so there's my spring, and we'll have to measure the lengths of these to make sure that they're providing enough tension. So this pin goes through the center of this spring, and what it does is it stops the spring from twisting in the bore and wearing in here. And then we've got one more ball bearing. Okay, there's our last ball bearing. This is our fourth, fifth. Need to undo and take this bolt out all the way. And if I just rotate that, I can just spin it, and then this should just slide out like that. So now I've got all my shift forks out. First thing I'm going to do is take my first reverse slider off, and I'm going to lay that right here. Then on the back of our gear set, we have two nuts. The intermediate nut, which has a roll pin that goes through it. This is a castellated nut. And then this is our pinion nut, or pinion stretch bolt. And this is a long bolt that goes all the way through. So the way I'm going to remove these is first I'm going to drive the roll pin out of here. And there's a couple of ways we can deal with undoing these bolts. You can use an impact gun if you're careful and wind it off without any problems, or we could slide this back into the transmission, use our special tool to locate and lock our input shaft, and then we can unscrew that, and if we've engaged a gear, then we can also undo our pinion shaft with the input shaft locked as well. And this is the other thing where your magnet tray comes in handy. Drop that right there. So when I remove my nut using an impact gun, I just take a shop towel, wrap it around my input shaft, and you'll see it'll pop off really nice and easy. And that's a 19mm deep socket that I'm using. And for my pinion, I'm going to use a 32mm deep socket. And same thing, I'm just going to grab my pinion shaft with a shop towel and pop my stretch bolt, just like that. Pretty nasty looking oil in there. So as a rule of thumb, when I'm doing a transmission, just to make my assembly easier, is you can see here I've kind of started two lines. So here's my input shaft nut and washer that I took off, and here's my reverse, first reverse slider. When you start pulling these pieces off, now this one can sometimes pop right off, like this one is. Sometimes you got to use two small pry bars and carefully pry it out. But what I usually like to do is just lay everything out in a line. So that way when I go for reassembly, it just makes it quicker, easier. You don't have to think too much and keeps everything nice and simple. So on the back here, I'm going to start pulling our gears off. This is our first gear. When it comes off, there's going to be a spacer and a needle roller bearing in there, as well as a thrust washer. So we want to pay attention to how these were orientated. It's fairly self-explanatory when it's going back together. Thrust washer is tapered, but if we lay it out in the way that it came apart, and then what I'll normally do is put my bearings and any spacers that go inside kind of above that gear, so that way I can look at it and see it easily. Gear here on our input should also slide off. If you do need to pry this one or use a puller, you do have to be careful. These will chip very easily. Pay attention on the removal that the flange faces towards the intermediate plate, so that way when you're putting it back together. All right, so I have our intermediate plate in our press, setting on two press plates, making sure that the gears aren't contacting anywhere on the press. Now on this particular transmission, this surface here and this surface here are the same height. If you are doing, say, a 901 transmission, then you'll need to use the special tool, which will look something like this. And what this does is it has a different height here on the pinion shaft for the input shaft, so it can press both out at the same time. All right, when we press these out, you've got to make sure that you can hold on to both gear sets. So I've got my hand underneath the press, and typically it won't take a lot of force to bring these down. You just want to make sure that they're both moving down at the same rate. And the gear sets are heavy, so expect them to drop. So the intake one just dropped. There we go, we're through. So here's our two gear sets. So I was hanging on just with the pinion sitting on the palm and my two fingers holding the input shaft. So I've got those out. I'm going to put those on the bench. So in our intermediate shaft, we have the second half of the bearings. These are called annular bearings, and these are very important. They're kind of one of the most important bearings for the transmission. These annular bearings control the end float on the gear shaft. So we're going to pull this apart and inspect the case and the bearings a little bit further on. For right now, I'm just going to put it off to one side and we'll come back to it. We're going to disassemble each individual shaft. Right now, what I want to do is just take a look at my bearings and see what kind of wear I can see, if any. Actually does not look in bad shape at all. Mike did give us some bearings that he had already purchased for this transmission, but we'll take a look and talk to him, see what he wants to do. I can also get a closer look at my Synchros right now. Only very slight wearing on it. Let's take a look at our third. Okay, third gear Synchro is starting to come apart. You can see right there, this coating is starting to kind of flake off. Probably definitely be putting a set of Synchros in it. It's got a little bit of wear right there. Second and third gears typically are exposed to the most amount of wear, but really not horrible looking at all. Then we can do the same with our input shaft. We want to look at our annular bearing at the back. This is the inner part of the race that we left on the shaft. Looks like normal wear. So we have our fourth gear and fifth gear Synchros right here. Fifth gear Synchro has a little bit of wear. Dog teeth don't look too bad. I can see a little bit of burring. We'll inspect those a lot more closely once we've got all the gears disassembled. So the way I normally do it is I'll break up one shaft at a time, so I'm not mixing things up. So I'm going to put my input shaft off to one side, and we're going to work on getting our pinion shaft apart, cleaned up and inspected. Okay, for the pinion shaft, These gears are loose, and actually I did feel there is a little bit of movement here on this spacer where these gear sets are moving. So this has moved somewhat. This is a press fit right here. It will not slide off, or it shouldn't do. We also want to take our bearing and shim pack completely off. So what I'm going to be doing is using a bearing separator. Whenever you're using these separators, you want to make sure that you are careful that it can't damage the gear in any way, shape or form. If a gear is damaged, that means replacing the ring and pinion. These are a matched gear set. So I have it set up like that. We're ready to go into our press. Okay, so when I'm pressing, I want to make sure my pinion shaft isn't going to hit my press plate, and I'm just going to use a socket to space this up. Okay, so there should not be a huge load on this. I am going to just put my hand here in case this shaft does drop, but I should be able to push most of it with just my fingers in the press, so I'm not needing to use the large bar. Alright, so that's free. I'm sliding the pinion shaft up and down. I've got my hand on it on the bottom. So all I'm going to do is roll this to the side and take it as an assembly over to the bench. So same as what I did before. Take my bearing off. There's my thrust washer. You can see this is a tapered thrust washer. Here's our gear set coming out next. Slider. And because I'm out of space here on my bench, because I got a bunch of other stuff going on, I'm just going to drop down. Next side. We're going to have a spacer, the gear, and you want to pay attention that this hub faces this spacer. Next one. Okay, in between our fifth gear fixed and our support bearing, we are going to have a thick spacer, and then we're going to have a shim pack. We're going to go through how to calculate this shim pack once we're ready for reassembly, but make sure you don't lose any of these. These can also be quite skinny, so you want to make sure that, like that one was stuck, that you get them all separated. And I'm just going to keep them off to that side. And then lastly, we have our bearing. Now this bearing, you also want to pay attention. It's installed with this race, so there's a thin parting line. This brake on this side is fixed. As you can see, there's no race on here, it's all one piece. This top part that seals the bearing rollers in needs to face the gear set. So if you're reusing, it's going to be assembled back on. If you're putting a new one, make sure that that bearing race faces the gears. So there's our pinion shaft all disassembled. I'm going to wash my hands, and then we need to disassemble our Synchro so we can take a better look at our dog teeth. To get our Synchros off so we can inspect them, I'm going to use a large set of circlet pliers, and I'm just going to go in here. I'm going to pop this open, and I usually will try and walk it up at the back because it's going to be fairly tight, and then kind of twist them out like that is going to be the easiest way to get those out. We do want to take a look for wear on here. Now you can flip these over when you reinstall, that's perfectly okay. I've done that many times. And then we've got our Synchros. This is going to be our actually synchronizer band. And I'm looking for a tight fit in the dog teeth, and it should be fairly firm. These are a little on the soft side. I'm just going to pop that out, and then inside on the gear itself we're going to have two brake bands and two anchor blocks. One is going to be fixed, and then the floating brake bands, and then this is going to be our floating anchor block, and that's going to sit like that. So we'll get the rest of those disassembled in the same way, and then we'll wash everything up and inspect. So if we take a look at first gear, it's a little bit different on the anchor block setup. And I'm just going to pop the Synchro off. So there's our Synchro. And what you'll see in first gear is there's only one energizer band, and both of the anchor blocks are semi-fixed or fixed. So we've got the one at the bottom that is fixed, and this one, unlike the rest of the gears, so if we take a look at the difference, this one's first gear, and this is going to be all other gears. Now, the reason behind this is first gear only needs to be synchronized in one direction. Second, third, fourth, all need synchronization in both directions. First gear, we are only downshifting to it. We're not shifting up to it from a lower gear. So it only needs to be synchronized in one direction. So I'm just transferring everything over to my roll cart so I can roll it over to our parts washer and start washing everything up. Okay, we're gonna just wheel this over to our parts washer. I'll wash up each individual piece, clean it, dry it, and then I'll come back and I'll lay it back out on our bench. All right, the next thing we're gonna move on to is disassembling our input shaft. So firstly, we're gonna need the tool that holds the back end of the input shaft so that we can undo our nut right here. So what we're going to use for the special tool, normally it was a metal piece that was splined similar to the ones that we used in our 915 transmission course. What I actually use is I have an old gear that I've got from an old transmission, just like that. I've ground the gears down so they're flat, and I'll go ahead and just put them right in my vise, and that'll hold my input shaft. Okay, so now I've got that input shaft held securely. What I need to do is peel up this locking tab right here. All right, so normally I will not reuse these lock tabs. They are still available. So next thing I'm going to need is my extra long 32mm socket. That'll go on to the input shaft so I can undo the front nut on the input shaft. Okay, we're going to slide that nut off. So the same as on our pinion shaft, we're going to have to press this gear setup. The bearing right here is what is locating our bearing. We also want to pay attention to the direction of the bearing, and on this one the cage is facing the input shaft. I have my little radial cutouts on my press plates, and it is just sitting flat on that gear, and then I'm just going to press straight on top of our input shaft. So I've got some load on it, and once again it shouldn't be a huge amount of pressure. So we're just going to disassemble our input shaft pretty much the same way we did with the pinion shaft. Okay, there's our input shaft all disassembled. We still do have a bearing on here. We'll get that off in a little bit. Same thing, I'm going to disassemble my Synchro so I can inspect my dog teeth as well as my Synchro bands and get everything cleaned up. Moving on, we're going to disassemble our intermediate plate. There's a few things that we're looking for there. We're going to undo the bearings. Now, the 902s and the early 901 transmissions were not too bad on the intermediate plates, the aluminum versions. In the magnesium versions, in the 70 and on, these intermediate plates were a real source of problems. These bearings could spin inside the plate, and they would actually lose some of their tension or their ability to hold the clearances correctly. So we want to make sure that the bearings are tight. There's no evidence of spinning in this housing. If this bearing has been spinning, and I don't anticipate it has, I can see the electric pencil for the matching number is still intact. So that usually it'll show signs here of polishing if it has been spinning, but let's get it apart and take a look. Okay, you always want to make sure that you use aluminum soft jaws. Okay, one of the first places where if you have had an instance where these bearings have been spinning in the housing is you'll see it right here. I've seen these that have had quite a big lip ground into them. This one actually looks pretty good, doesn't look like any signs. I'll have to clean it up in the parts washer to see 100%. Looks like the oil that was in it was pretty dirty too. And I'm just pressing on these bearings to see if they're loose, which they're not, which is great. So we'll need to, we'll probably wash this first, get some of the oil off, plus my parts washer is heated, so that's going to help with heating up this outer plate, so when I press them out it's going to put less strain on the metal-to-metal interference fit when I press them out. I've got the housing mounted on our stand, and what I'm going to do right now is just drop in my differential. And once again, we didn't do the original disassembly on this, so I didn't get a chance to kind of see where the preload settings were. And before I pull off the side bearings to replace them, I want to see where my preloads are right now. I'm going to put a little bit of load on this cover, and then I'm just going to use my feeler gauge to measure what kind of clearance we have here. So I've just nipped those down by hand, and what I'm looking for is a preload clearance around 0.15 of a millimeter. Now the 902 transmissions do run a gasket. They don't use an O-ring like the later 911 transmissions or 915s. So that gasket, we don't have a new one here right now, but usually they are going to be around 0.2 of a millimeter thickness. So for this quick measurement, we're going to assume that that is going to be our gasket size. And so 0.2 plus 1.5, we're looking at 0.35 of clearance on here for the correct bearing preloads. And 0.35 is no chance, oh, goes in right there, but really tight. So I'm just going to drop my feeler gauges down until I find the feeler gauge size that goes in. All right, 0.20 goes in, but it's pretty tight, a little bit looser over here. Pretty firm right there, and that can be a product of if this nut is down a little bit more than this one. So 0.2, but I can't get it in all the way around. Balancing of this will make a little bit of a difference. So if I can fit 0.2 in here and it's loose and I can't fit it in on this side, let's see if we go up down to 0.15. Can't even get the 0.15 in. Right there. So I'm going to put our clearance at 0.20 of a millimeter for a rough check right now. So since I don't have a gasket in there, when that gasket goes on, that means there is going to be no preload on these side bearings at all. That can be a function of the bearings being worn out, or it can be a function that the preload may not have been set up correctly the last time this transmission was rebuilt. So now when I pull my side bearings off, I'm going to look at my S1 and S2 shim pack sizes and record those. We'll still have to measure this with new bearings, but at least now I got an idea that we might be a little on the low side. Okay, so one of the last things we have to disassemble for inspection is going to be our differential. So what I'm going to do while it's still in the housing down this shaft on the early 901, 902 transmissions is a roll pin, and that roll pin holds the cross shaft for the pinion gears in the open differential. I want to drive that roll pin out so I can disassemble those gears and wash everything correctly. So I'm just going to take a 4mm punch and carefully drive that roll pin out. It is going to pop out on the floor below me. There it is. Alright, so now I've got that roll pin out. What I'm going to do is push this shaft. You can see the whole assembly moving. That roll pin stops this shaft from moving, so I'm just using my fingers to press it out. So I'm just going to help it with a little brass punch. Okay, so there's our pinion shaft. And let's go ahead, and what we should be able to do now is pull out the main shaft. Then to get this gear set out, we've got our sun gears and our planetaries. All we're going to do is rotate it sideways, pop out one, bring it back the other direction, pop out the other one. Doesn't matter where these go. And then we're going to have our side gears or main gears should slide out after that. And you just got to get these on the right angle to pop them out. There's two. Alright, next thing I want to do is pull my bearings off, and I want to make sure, like right now I'm pulling on these, make sure these are a tight fit. Sometimes these early housings, these bearings were prone to spinning, so if they're loose then that's going to indicate that we have a bad housing here. But let's pull these off. Take a look at what shims we have installed for our S1 and S2 shims. If we take a look down on the side here, we can see there's a little cutout in the cast iron. This lets me get my little two-legged puller in. I have an adapter on this housing, so that's going to allow me to put my two-legged puller against it, and then I should just be able to wind this up and pull that bearing off, just like that. So we're also going to have our shim, and this is going to be our preload shim as well as our shim for adjusting our backlash. So I want to keep these in order right now. Looks like it does have some signs of spinning, but we'll get it cleaned up and take a better look at that. You want to make sure too that you're all the way underneath. If we're just pulling on this cage, you see here I have tension on it, and this is still nice and light and can spin. If you just get your puller underneath here, what will tend to happen is this cage will just blow apart. Now this side is a lot tighter. Can't wind it with my regular wrench, so I'm going to grab my impact gun and wind this down. There we go. But a nice tight fit on our housing. So this side, things are looking pretty good, but on this other side we may have some wear to deal with. Let's get it cleaned up, take a look at what it looks like. When it comes to the ring gear, I do not normally take them off of here unless I have a reason to take them off of here. So leaving these bolts in and these lock tabs is just fine. Unless you're doing a ratio change or you have to change the carrier, then definitely nothing to worry about. Don't go attacking these for no reason. So I have everything now disassembled into its individual sub-assemblies. I've got Synchros broken down, we've got the Differential broken down, we've got the Pinion shaft all broken down. Everything has been washed and cleaned. So now we're going to go through and do our inspection and base measurements, see what parts we need to order. There are some things that we can't do until we get like new bearings for bearing preload setups, but we can kind of look ahead and see what shim sizes we may need. Starting with our intermediate plate, I've got no signs of bearing spinning. Our retaining plate is in good shape. Our bores, you can see, are nice and polished. Bearings have not been spinning at all. Both bearings were tight. Input shaft was a little bit tighter. It's a smaller bearing, tends to go that way. No abnormal wear. The gasket surfaces are in good shape. Even down, I want to make sure my threads here are good. Now there are little tiny sleeves installed. There's a metal sleeve in here. Normally I will not remove those just because there's no reason to, but you do want to make sure they're still in place and don't move when you pull all of this detent system out. These did not, so this one's all good. Ready to reuse. Moving on to our differential. So there's a few things here that we want to look at. We have firstly all of our pinion gear set up. So we have our two side gears or sun gears and our two planets that are rotating around these. Now these gears will typically look pretty ugly. They are not like a normal running gear in that on the sides, and you can see we've even got a little bit of rust forming. The gear mating surfaces are not exactly super pretty. Now with this is going to sit for any length of time, I will hit it with a little bit of lubricant just to stop that surface rust forming, because even though they usually look pretty ugly, we don't want them to rust up while we're waiting for our parts. So the surfaces I'm mainly looking for are my thrust surfaces right here, and also how they feel in the pivot shaft. They should be nice and smooth, shouldn't have any excessive wiggle side to side. I'm also looking at my shaft here, the same thing. I don't want to see any scoring or anything to indicate that these have run dry. Okay, on our ring gear, what we want to be looking for here is any abnormal pitting. You want to look on both sides of the tooth. Normally what you will see, depending on the mileage, is a polished section of the tooth. What I'm looking for is any abnormal either pitting, where it means it's gone through the case hardening, or any heavy wear grooves that I can pick up on a fingernail. And once again, check both sides of the tooth for that. Next thing I want to look at is back onto my carrier is this bearing surface. So here we've got, this is S2 is the shim pack out here with the side bearing. This one, normal staining, looks fine though, feels smooth, no lips. But if we come up onto S1, we can see that we've got some heavy scoring. When I run my fingernail over, I can catch it in this groove right here. One of the other dead giveaways was our S1 shim. It is heavily scored, and it's actually scored to the point where it's reduced the size of that shim. So this shim is no longer viable in that all the case hardening's been worn through, and what it means is this bearing was actually spinning on this housing. Now when we did our pre-measurement, we saw that we didn't have any preload. It was at a 0 bearing preload. That is definitely going to have contributed to that failure. Could also explain why our numbers, we had no preload. It's kind of a catch-22. If the preload was set too soft to begin with, and the bearings, once they settle in, the load, side pressure came off of them. This allows this differential to move slightly back and forth. Also reduces the clamping load on the bearing itself, and it's allowed to spin right here. So this one, the carrier, is not going to be reusable. We're going to have to find a new carrier for this differential. That's also going to mean we're going to be undoing all of these bolts and transferring our ring gear over to a new carrier. This is because the ring gear is matched to the pinion shaft, and they do have to be replaced as a matched set. What I'm going to show you is the difference between replacing something and something that may look bad and need replacing but really doesn't. What I'm going to do is just Scotch-Brite that piece, and if it rubs off, nice, you don't have to replace it. But if it rubs off and yet you still have a shadow, and what we're seeing on this one is I have a definite corrosion right there. The real tell is when I bring my fingernail over, can I catch my fingernail in it? And does it feel rough? If it feels nice and smooth and it's just staining, no big deal. This particular piece, actually I can see the corrosion. Now I've cleaned the staining off, and when I drag my fingernail over it, I can actually catch my fingernail in it. So this one's going to mean that I'm going to need to replace this inner bearing. I'm going to replace my needle roller just because I'm replacing my inner bearing. On the gear itself, I did the same thing as I took my Scotch-Brite and just worked it and polished it. And in some spots, I mean, for the most part, everything cleaned up really nice. I've got some very light staining still there, but the difference is it's perfectly smooth. There's nothing to catch my fingernail in. It's just a stain in the metal. So we don't have to replace the gear, but we are going to end up replacing the inner bearing race and the bearing. Alright, so that covers checking our gears and checking all of our synchros. The same is going to go on your pinion shaft. What I'm going to do is check my sliders and my synchros. So these clearances, brand new, should be 0.1 to 0.3 of a millimeter, and that clearance is the side-to-side clearance when it's inside the actual sliding ring. 0.1 is the minimum, so I'll start there. Yep, that slides in, goes in nice. 0.15. Okay, that feels like the actual clearance. It starts to tighten up in the center. Typically the most wear will happen at the ends. 0.2 will not go in. So this Synchro fork is good, or selector fork, and then I'm going to check it again. If something was really close to the wear limit, I would check it against its specific slider just to make sure it wasn't this part, but mainly we're checking our actual selector forks. And this one feels about the same. 0.15 is tight at the top, nice fitting right here, and a 0.2 will not go in. Okay, so this is our first reverse slider, and we're going to check our selector in the same way we did. The specification is the same. It's going to be 0.1 to 0.3 is the new dimension. 0.1 goes in very easy. 0.15 goes in very easy. 0.25, I can force it in at the high wear spots, but really 0.20 is its actual number. So there's a little bit more wear in this one if we were looking at minimums, but this tolerance is 0.1 to 0.3, so well within that tolerance range. So this fork is good. Okay, a couple of points on the pinion shaft. Checking synchros, checking all your bands is all exactly the same. Same thing here. We had, this one is one that I polished and was actually able to clean it up very nicely. It was suffering the same with staining, but no issues, we'll be able to reuse. We have a set right here, first gear, and these ones I am going to recommend to replace. They are not the worst I have seen, but definitely in a number of locations you can see where the tooth is rounded. And then that also coincides with our slider. You can see the teeth here are not a really nice sharp point. So I'm going to recommend to replace these just to bring it back to a new condition. If I had to, I could reuse them, but what the effect in the car might be is difficulty in selecting first gear. So first gear can sometimes be a little bit of a challenge on these cars anyways. It's not a big deal to replace just the dog teeth. I don't have to replace the entire gear to do this. We can press this off and press on a new tooth assembly. Over here is going to be our pinion shaft. So on the gearing here, same as our crown wheel, we want to check for any abnormal signs of wear or pitting on both the drive side and the coast side of the tooth. And as well as the shaft, we want to make sure none of the bearings, where bearings are mounted, like here and here, there's been any signs of bearing spinning or excess heat. Everything feels fine there. We have two numbers. The top number right here, this is going to be the matching number to the ring gear. The next number that we have here is going to be the pinion depth setting, and this one is minus 0.20 of a millimeter. So there are still some points we haven't covered on the case. That's going to be setting our side bearings in here. We need to knock both of these out and make sure that they're still reusable. The outer cover, this is the differential cover, that's not as big a deal as something, say, like if this inside bearing has spun and is really loose. There's some things we can do to save that if it has, and some limitations that we have if it's gotten too big. Same for here. I'm just checking my support bearings right here and seeing if there's any movement. If I can spin these with my fingers, then that's going to be an issue. But right now these feel pretty good. I've still got to drive those out and address any issues that are going on there. Now we've got pretty much all the information we need to order parts. A couple of things that we need to know. One is going to be the transmission type. This is a 902/1. And this is the actual transmission serial number. You need to write both of those numbers down, so when you are ordering components, especially if there's choices for transmission brakes at serial numbers, you need to know that. And the type here is going to designate what the original gear ratios were going to be and things like that. So that pretty much wraps it up for cleaning and inspecting. Now we've got to go chase some parts and quote Mike how much it's going to cost to put this back together.